Now we're going to look at levers closer to home. We're going to look at the principle of how leverage works in your body. Now right here, I have this little thing that pivots, and I have a rope which is connected to it. And the rope connects at a big distance here, but in this case, it connects to small distance. So these are exactly the same weights.
Okay.
And if you're going to pull on these two ropes and going to lift those two weights by pulling on the ropes, in which case am I going to have to pull harder?
I want to say on the short one.
On the short one. Because I have a short distance.
More force.
Big force. Oh, yes.
Oh, okay.
Because these two things, gravity's pulling them down exactly the same. But I'm going to need a bigger force because I have a short distance. So try it and see if that's what you find.
Okay.
You pull it too? Oh, yeah. Yours doesn't even want to go. There it goes. There it goes. Way more force. Way more force. And you actually have to supply a force that is like 6 times its weight in order to lift that. Whereas this one, it's just about its weight. So Taylor, go ahead and try that one and see the difference. I mean, you really have to work. You have to work to get that one to go.
Wow.
Now, there's a place. Think about something in your body. Think about one of your joints that looks like this. Can you think of something that looks like this? Kind of bends up like so.
Maybe your arm?
Your arm. Your elbow.
Like your elbow?
Exactly. This was intended to model the way your elbow works.
Oh, okay.
And it turns out your tendon that pulls your arm up attaches very, very close to the joint. And here's what it buys you. I've got a short distance here, okay? So watch how far. I'm going to pull this out about this far. Do you see how far the weight moved?
A lot.
Moved a long distance. Moved a long distance. So I'm applying a big force in a small distance. Out here, I'm getting a smaller force, but I'm getting a bigger distance. And so what happens is the way your skeleton is put together is that the forces that your muscles apply are usually applied very close to the joint. As a consequence, the forces are very large, but the distances are bigger. Okay? The distances are very, very bigger. Now, we're going to take a look. We have Corey over here joining us in the studio.
Oh, yeah.
And go ahead. McKenzie, go ahead and roll Corey in here so that Corey could do some experiments with us. Now, here's the way your elbow joint works. There's a joint right here. There's a pivot. You apply forces out here. So if you hold your hand out like this and you're lifting a weight, you're lifting weight out there where your hand is. I'm going to lift weights here. So if we have a weight in Corey's hand, the tendon that makes that happen is actually attached right here. It's actually attached right there. So and you can feel this on yourself. You can feel it. If you take your arm up like this, can you feel that tendon?
Oh, yeah, right here.
That's it. That's the piece that's actually pulling. And you can see it's really close to your joint. It's very close to your joint. So as a consequence, the force is bigger. And let's do a little experiment on Corey and see how that works. So I'm going to take Corey's hand, pull the hand up like this. We're not worried about weight. McKenzie, you're going to use a probe and you're going to pull here. Taylor, you're going to use one and you're going to pull here. And you're each going to tell me, you're going to balance your forces. And I'll go ahead and hold the arm up. Okay. And so Taylor is pulling with about 1. Mackenzie is pulling with
6.
6 times as much force as Taylor is applying. And that's because Mackenzie is applying a force close to the pivot. Taylor is applying a force far from the pivot. But this actually works like this in your body. We've got
those arms again.
Oh, yes, those arms again. And Taylor, why don't you go ahead and put this on. And then go ahead and back up a little bit so we can, oh yeah, there we go. And what I'm going to do is I'm going to put a weight out here, okay?
Oh, jeez.
So, and you're going to try to hold this up. This is like 1 can of soda, okay? Okay, and let's try this one. 1 can of soda right here. And you have to work pretty hard to hold that up. And we're giving you a bigger distance, and so we're getting that longer lever arm, getting more force. There's 2 cans, and you can just barely hang on to that. 2 cans of soda. And if I want to move your arm down, it is not a trick to do that. It's not a trick to do that. So if you have longer arms, you can apply a lot less force. And we have pretty long arms as like animals go in terms of the attachment. But what it gets for you is this. If you take this hand and move it up like this, go ahead and move it. Watch what happens. Watch how far the hand moves. Oh, yes. It gives you big distance at the expense of force. Lots of distance, not much force. Excellent. And let's look at your shoulder joint. So I want you to hold your arm out like this. And you have muscles which are holding it up. Now arm out to the side. And do your arm like this, like with your thumb up. Go ahead and put your thumb up, okay? The muscles that are holding this up are really, really close to the pivot. Can you feel the muscles? That distance is really small. So as a consequence, I can push your arm down like pretty easily because I'm way out here at a large distance. To do this with McKenzie, I'm going to hang this off the end of your arm. See if you can hold this up. Arm all the way out.
Oh, that was hard.
That is hard. And that, 45 newtons, this is 10 pounds. So you can hold 10 pounds. It's not so heavy, but at the end of your arm. And you can make the situation worse. Taylor, your turn, except I want you to turn your hand like this, thumb down. And that makes the situation worse. So all the way out the end of your arm. Arm straight out.
I can't even hold it.
Straight out. And if I put this on, you can't.
Like
you can't.
automatically drop.
It does. It does. And it's just because the way the muscles are pulling is not very effective. And it doesn't take very much to kind of like make your arm go down.
Oh, okay.
So you can't apply very much force out here, but what you do get is lots of
So longer distance, less force, but smaller distance, more force.
more force. And you
Oh,
can't
okay.
apply enough force to make that happen.